Dear learners, hope all of you are fine. I am also fine. This is FM Yusuf, Assistant Professor, Department of Chemistry, Milestone College. Dear learners, in my previous lecture, I discussed about the definition of organic compounds. Today, I would like also discuss about organic compound very broadly. So, look at the whiteboard. Organic compounds. This is methane. This is the structural formula of methane. I am sure that you understood that methane is a hydrocarbon because methane is formed by carbon and hydrogen only. Now, if one hydrogen atom is replaced by chlorine and the another carbon hydrogen bonds remain unchanged, then the name of this compound will be methyl chloride. So, dear learners, I can say this methane and methyl chloride is a derivative of methane. So, as methane is a hydrocarbon, so of course methyl chloride is a derivative of hydrocarbon. So, come to the definition. Hydrocarbon and their derivatives are called organic compounds. I would like to show you another two examples also to make it more clear, to make your conception more clear. Suppose this is carbonic acid and this is methanol or methyl alcohol. Methanol or methyl alcohol, both of the compounds contain carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen. But methanol is an organic compound. Carbonic acid is not an organic compound. It is actually an inorganic compound. What is the reason? The main reason, if one hydrogen atom of methane, one hydrogen atom, suppose this is the structural formula of methane, if one hydrogen atom of methane is replaced by OH group, I mean hydroxyl group, then this is known as methanol or methyl alcohol. So, I can say methanol is a derivative of hydrocarbon. That's why methanol is an organic compound. But in case of carbonic acid, it is not a derivative of any hydrocarbon. Carbonic acid is actually produced by the reaction between carbon dioxide and water. That's why carbonic acid is an inorganic acid. So, dear learners, I think all of you got the clear conception about the definition of organic compound. Now, I would like to show you a difference between two compounds which was set in the board question. Now, look at the whiteboard. Suppose this is a compound. Dear students, all of you know that this is a closed chain compound because the terminal carbon atoms are connected with one another. And in case of closed compound, I taught you have to write the cyclo word at the initial point of the name. Then this is bute, because 1, 2, 3, 4 bute, cyclobute, and due to carbon-carbon single bond it will be N, butane. Dear students, I will teach you about the naming process of organic compound in my next lecture. However, this is cyclobutane. Cyclobutane also can be written as just a sign of a square. This is also cyclobutane. And again, if you consider another compound, of course it is also cyclic compound. This is also cyclic compound, and to write the name of this compound 1, 2, 3, 4, the name of this compound is cyclobute, as there is one carbon-carbon double bond, that's why it will be in cyclobutene 1. I mean carbon-carbon double bond is at the first carbon. Cyclobutane can be written also as like this. You have to write a square and you have to give another straight line in the inner side of the square. However, what are the differences? I mean, what are the similarities between two compounds? I mean, cyclobutane and cyclobutene 1. First similarity is both of them are hydrocarbon and both of them are closed chain hydrocarbon. And dissimilarity is cyclobutane contains carbon-carbon single bond, but cyclobutene 1 contains one carbon-carbon double bond. As it contains carbon-carbon single bond, it is a saturated hydrocarbon. As it contains carbon-carbon double bond, it is an unsaturated cyclic compound, or it is an unsaturated closed chain hydrocarbon. So dear learners, already you have understood what is the differences between cyclobutane and cyclobutene 1. Okay, dear learners, I would like to show you about the aromatic compound. In my last lecture, I told you a very short definition of aromatic compound, and there I have told you benzene and benzene-like compounds are known as aromatic compound. Benzene and benzene-like compounds are known as aromatic compounds. Aromatic compounds. Though in my last lecture I taught you only the definition of aromatic hydrocarbons, but today I have written here aromatic compounds. It is more vastly than the aromatic hydrocarbon. However, first one, I would like to show you the structural formula, the orbital figure of benzene. As you can say, benzene is the mother compound of aromatic compound. That's why I would like to show you the orbital figure of benzene, though it is not in your textbook. But to understand about the aromatic compounds, you have to know about the orbital figure of benzene. However, look at the whiteboard, dear students. You know that in the benzene there are 6 carbon atoms. There are 6 carbon atoms in the benzene, and those carbon atoms are placed at each of the corners of a hexagonal shape, and those are actually orbitals where the electrons are available, and those orbitals take part in the bond formation by the partial overlapping. Here actually the overlapping of orbitals are occurring sidewise. This type of bond is known as pi bond. Dear students, you will study it in class 11 and 12. However, I would like to show you the orbital figure to make you understand that there are actually a coplanar. Benzene is a coplanar cyclic compound. In one plane, the electrons are moving and the whole benzene structure. This type of electrons are known as delocalized electron. Those lobes are actually p orbital, and the p orbitals take part in the bond formation, which is known as pi bond, and the concerned electrons are known as pi electrons. Those pi electrons can move the whole benzene structure freely. That's why those pi electrons are known as delocalized pi electrons. So this is a coplanar cyclic compound, and there is a 4n plus 6 number of pi electrons. Coplanar cyclic compounds means it may have 5, 6, 7 or more carbon atoms. That's why I can say here benzene is a 6 members of coplanar cyclic compound. It contains 4n plus 2 number of delocalized pi electrons. 4n plus 2 number, 4n plus 2 number of delocalized pi electrons, where the value of n is equal to 1, 2, 3, 4 whole number. Suppose if you consider benzene contains 6 pi electrons, 1, 2, 3, 4, 5, 6 pi electrons. That's why I can write here 4n plus 2 is equal to 6, or 4n is equal to 6 minus 2 is equal to 4. So n is equal to 1. As the value of n is whole number, so benzene is an aromatic compound. And benzene, if I show you the structural formula of benzene, this is the structural formula of benzene. You will see that there is a alternative carbon-carbon double bond. But as benzene contains alternative carbon-carbon double bond, it is an aromatic compound. Actually, I am telling you the aromaticity, I am telling you the properties, the conditions of aromatic compounds. So already I have told you the first one, it must be a cyclic compound and coplanar. It has a coplanar, it is a coplanar cyclic compound, first one. Second one, it contains 4n plus 2 number of delocalized pi electrons, where the value of n is equal to whole number. It is, the third one is, it has alternative carbon-carbon double bond. I mean, first there will be a double bond and one single bond, and then again double bond, then single bond, then again double bond, then single bond. This is actually known as alternative carbon-carbon double bond. That's why I can say benzene is an aromatic hydrocarbon. Dear students, the formula of benzene also can be written as just a hexagonal sign, and you may write the alternative carbon-carbon double bonds like this, even though you can give a circle sign in the inner side of the hexagonal shape, then it will be the formula of benzene. However, dear boys, I am sure that I could make you clear about the aromatic compound, about the characteristics of aromatic compound. Now again I would like to show you that you may ask me, sir, if one compound, suppose CH double bond, CH single bond, CH and again double bond, you may ask me, sir, this is 1 2 3 4 cyclo 1 2 butadiene. Cyclo 1 2 butadiene. Dear students, you may ask me, sir, cyclo 1 2 butadiene contains alternative carbon-carbon double bonds, double bond, single bond, double bond and single bond, and it is a closed chain. I mean, it is a cyclic compound. So why doesn't cyclo 1 2 butadiene an aromatic compound? You may ask me this question. Yes, but it is not an aromatic compound, because if you count the number of delocalized electrons, pi electrons, 4n plus 2 is equal to 2 and 2, 4. Each of the carbon-carbon double bonds contains 2 pi electrons. So 2 plus 2 is equal to 4 pi electrons. So here 4n is equal to 4 minus 2 is equal to 2. So n is equal to 2 by 4, I mean half, fraction. As the value of n is not a whole number, that's why cyclo 1 2 butadiene is not an aromatic compound. It is actually an aliphatic hydrocarbon or aliphatic organic compound. So that's all about the aromatic hydrocarbons. Dear students, now I would like to give you the another examples of aromatic compounds again. Suppose phenol. If OH group is directly bonded with the benzene ring, then the compound is known as phenol. Phenol is an aromatic compound because it contains a coplanar cyclic benzene ring. Coplanar cyclic benzene ring. Actually, phenol is a derivative of benzene. You know that benzene is an aromatic hydrocarbon, and one hydrogen atom, there was one hydrogen atom, it was replaced by OH group, and OH group is bonded with the benzene ring directly. That's why phenol is a derivative of benzene. That's why phenol is an aromatic compound. Again, if you consider, if you write the bonds of phenol, phenol contains, benzene ring of the phenol contains alternative carbon-carbon double bond, and it contains 4n plus 2 number of delocalized pi electrons, where the value of n is 4n plus 2 is equal to 2, 4, 6 is equal to 6. So n is equal to 1. I mean, in case of phenol, there are 4n plus 2 number of delocalized pi electrons, where the value of n is equal to 1. That's why phenol is an aromatic compound. So, dear boys and girls, now I would like to discuss about the homologous series. Homologous series. First, I would like to give you some examples. CH3 bond OH, methanol, CH3 bond CH2 bond OH, ethanol, CH3 bond CH2 bond CH2 bond OH. This is propanol 1, and now if I write here the molecular formula, 1, 2, 3, C3, hydrogen 3 to 5, 7, 8, H8, O. This is H7OH, C2H5OH, and it's as well as this is CH3OH. However, dear students, methanol, ethanol and propanol, all those compounds contain a common functional group OH, and those compounds can be represented general formula CnH2n plus 1 OH. If you put here n is equal to 1, it will be C1 hydrogen 2 into 1 plus 2, I mean H3 and OH. If you put here the value n is equal to 2, it will be C2 H2 into 2 4 plus 1 5, C2H5 OH. And again, if you put here n is equal to 3, C3 H3 into 2 6 plus 1 7 and OH. So dear students, I have shown you that all those compounds can be represented by a common formula, and this OH is actually known as functional group, though I will discuss about the functional group very broadly, but I would like to show you that shortly about the functional group. Suppose methyl alcohol reacts with phosphorus pentachloride to produce methyl chloride, phosphorus oxychloride and hydrogen chloride. Here actually only OH group takes part in the chemical reaction, and again if I show you ethanol C2H5OH, this is ethanol plus phosphorus pentachloride. Here OH group will be replaced by chlorine, and the another part of the compound C2H5 will remain unchanged. This is ethyl chloride, phosphorus oxychloride plus hydrochloric acid. And again, if I write here CH3OH, CH3H7OH, C3H7OH plus phosphorus pentachloride, here also OH group will be replaced by chlorine to produce propyl chloride plus phosphorus oxychloride plus hydrochloric acid. However, dear students, I would like to share, say you only the OH group, OH part of those compounds take part in the chemical reaction. That's why bond OH group is a functional group, and OH is a functional group of bond OH is a functional group of alcohol. And the characteristics of functional group, first one, the characteristics of homologous series. First one is all those compounds contain a common functional group. All compounds can be represented by a general formula, and all compounds can be synthesized by a general formula, and in between two consequence member there will be only a methylene group. There will be a difference of a methylene group, I mean bond CH2 bond. This is methylene group, and the mass of methylene group is 12 plus 1 into 2 is equal to 14. I mean the difference between two consequence members of a homologous series is a methylene group, and if the compounds containing same homologous series and same elements are arranged according to their increasing molecular mass, where there will be a difference of a methylene group between two consequence members, is called homologous series. And the first characteristics of homologous series are formed by same elements, atoms of same elements. Number 2, homologous the compounds of homologous series contain same functional group. Number 3, all compounds can be represented by a general formula. That's all about the homologous series. Dear students, in my next lecture I will again discuss about the organic compounds more vastly. So no more today, and goodbye.